Welcome to another episode from Martin's Tube Amp Workbench for all you guitar nerds out there. On my workbench this time we find a miracle in black Tolex, and later on I will explain why I call that amplifier a miracle. Actually we have a Silverface Vibro Champ on the bench, and it is an export model made in USA but made for Europe. This tag that is still hanging on the AC power cord tells us this amp requires a wall voltage of 240 AC, and even the European color code of the 3-prong cord was noted on this tab. But how old is this unit? Well, the tube chart won't help. It's not really in good conditions. Maybe the speaker code might tell us something. Speaker code? What speaker code? We don't print no code on this shitty cheapos. The mouse poo won't tell us either how old this amp is. But hey, we can always lean on the good old shoemakers. So either we have a 68 or a 78 Vibro Champ on the bench. But no doubt it's a 78. Why? Because of the plastic coated wires instead of cloth wires in older amps, and because of the waxed eyelet board. But what happened in 1978? Well, two things occurred that changed the world. And I'm not talking about politics, economy, or science. No, the little yellow Lego man entered the scene, and a cat named Garfield was born. No, you're not stupid. The real champ is on my bench. But now let's get serious and let's take a look at our patient. And here's the first reason why I call this amp a miracle. It's absolutely in original conditions. Nobody tinkered around, modified anything, or did some other sloppy repair jobs. All original, unmolested. This is something that happens pretty seldom. Most of the time you find at least some bullshit that has been done over the years. And if you watched my other videos, you will know what I'm talking about. Well, here's the faceplate. Despite of some minor scratches and some discoloration, it's in pretty good shape. Another miracle when you consider the age of this amplifier. The backside of the chassis is almost flawless as well. My customer plays in a small formation. They're doing kind of folk music and Americana, so he wants to use that amplifier for gigging, not as a collector's piece. So my duty is to check everything and at least do a recap, because the electrolytics are too old to be reliable. Okay, let's go. I will start with the can capacitor. I cut the wires instead of desoldering them. They are long enough so I can make sure that we have fresh and clean strands for the new connection. Desoldering the flaps of the can from the chassis is always a little bit painful because you need a lot of heat to loosen them up. So as you can see, I have here my Godzilla iron to apply enough heat to the chassis. Alright, and here it is, the old Matteray can capacitor. say goodbye to this old fellow. The next step is changing the bypass capacitors. By the way, this amp has a quite interesting story. The boss of my customer found that thing in his attic. He didn't know what to do with it, so he asked my customer, "You are a guitar player, right? Do you want that tiny little amplifier, or should I throw it in the junk pile?" Well, guess what my customer told him? And, well, he got that jewel for free. Unbelievable, isn't it? Maybe I should consider this when I write my bill. The new bypass capacitors are really nice. They have the same color like the original ones. They are made by a company called Mod, M-O-D. And I think there are really nice replacements for amplifiers from the 70s. They look right. And now it's time to drop in the new can capacitor. Well, here we go. And here it is. Looks nice, doesn't it? And here's another miracle. I tested all of the resistors and only one of them tested out of spec. Look, here's the one. It's the dropper in the power supply. And we should read 1K, but look, it's 1.7, almost 1.8, way too high. But I was lucky. I found a carbon resistor, 1K, 1 watt, in my stash. So we have the period correct look. Let's check the coupling capacitors for leakage. Well, I don't expect a lot of trouble there, because usually these blue molded caps never fail. And sure enough, you can see on this side of the capacitor we have around 5-6 millivolts. That's pretty perfect. Oh, goes down to 0. The other one as well is doing its job, and it's blocking DC. Third one, we read 198 volts on one side, and on the other side it's perfect too. We are in the millivolt range, no problem at all. Let's check some voltages now and see if everything is okay. 374 volts, 348 volts. Okay, that's good. And let's check the voltage on the plate of the power tube, 368 volts, 373 volts on the grid. Well, the schematic calls for 340 42 volts on the plate. We are a bit higher, caused by the higher wall voltage that we have today in comparison to the 70s, but that's nothing to be concerned. But how about the plate dissipation? Let's take a look. We have 343 volts between the plate and the cathode. We have a voltage drop across the resistor of 25.7 volts. And the resistance of the cathode resistor is 510 ohms. And that means that we have a plate dissipation of 16.8 watts, and that's definitely too high. A 6v6 output tube calls for 12 or 14 watts. That's why I have to talk to the owner if he wants me to increase the cathode resistor. But to be honest, this amp has been working like this for decades now, so why bother? Let's do a quick test now and see if everything works right. Yeah, sounds nice and is dead quiet. But before we reassemble that thing, there's another thing to do that my customer requested. I have to change the hardware. It's rusty. Fender still offers the right parts, no big deal to get them, and pretty inexpensive. Well done, Fender. Well, after I removed some spots of wall paint and wood paint, it's now time to throw everything together again. Get the chassis back in. And to be honest, man, at the first glance when you look at that thing, this beauty really looks like a reissue. Everything is in such good shape and, well, it's beautiful. My only recommendation is swap the speaker. When my customer wants to use this little amp for gigging, he wants to carry that thing around in little clubs and, you know, he wants to play it. So it's a good idea to get a new speaker because these little 8-inch Oxford speakers are very wimpy and weak. A new speaker is more reliable and it even sounds better, that's a fact. But before we listen to this miracle in black toe legs, I want to take you on a little journey to a very common tool from the tube era. It's my trusty old tube checker from 1966. Some viewers asked for this in-depth look into this unit. So yeah, let's take a look at this tube checker and see what we find inside. This tube testing device was a kit supplied by a company named Commercial Trade Institute, but it's got the same circuit like some Heathkit tube checkers from these days. We have a few different tube sockets, and for our purposes we need actually only two of them. The 9-pin socket for preamp tubes, it's the brown one, and the 8-pin tube socket on the far right. Here we can dial in the heater AC voltage. Also the time we need 6.3 or 5 volts for the tubes, and this is the line adjustment pot to set the meter. Here is a short indicator lamp, and a switch to set the kind of tube we are testing. This pot sets the load resistance for the different tube that's required. And here are the levers to set the different pin layouts. With the tester came a bunch of charts with the setting for hundreds of different tubes. But actually, this tester is a very simple and basic device. We can test the emission of the amount of electrons that flow by flicking the switch. And you can read on the meter if the tube is good or bad. The short indicator lamp lights up when there is a short inside the tube, which can happen between the plate, the cathode, the grids, or heaters. But we can also test the filaments and the internal connections for continuity. So let me show you some testings to give you an idea what might happen. So here's the chart. Everything is set up to the right configurations. We see no short. Boom, this tube is strong. We hold the test switch and move the certain levers to check the tube for open elements. The needle moves, so this tube is okay. But here we have another example. You see the short indicator light is glowing, and this example is bad. This tube is ready for the junk pile. The schematic makes one thing clear that I mentioned before. It's a pretty simple design, but let's go a step further and open that thing up. So here we go. A look at the guts. Here you can see the transformer that provides a lot of different voltages for all kind of testing. This is the back side of the meter. This circuit here feeds the short indicator lamp. This is a switch that dials in the heater voltage. And we have a rheostat, a wire wound potentiometer that adjusts the meter. The load switch with different resistors to set different types of loads for the tubes. And last but not least, the lever switches for the pin layouts of different tube sockets. The back side of the tube sockets, one of them is a replacement. I added a 3-prong cord. You can see the safety ground here. A few of these old components are changed out, like the resistors and the capacitor, to make that thing more reliable. Of course, I added a fuse as well. You never know. So that's it about my tube checker from 1966. And now let's get back to the Miracle in Black Tolex and listen to its miraculous sound.